All right, so if you notice, this one's in white. That way I don't mess up the colors this time. But I didn't change this color, but I mean, you should be able to read that. So we're going to determine the probability of a compound event using multiplication this time. So before we use like the tables, right? And then we use like tree diagrams, whatever. Now, this time, like I'll show you another way, which will make it easier. Okay, less time consuming, but it only works like it's more along the line of like a procedure that works, that you can get into why it works, but really this it does this without drawing it. Okay, so we're going to spin and roll. So blue, red, yellow, blue, red, yellow. I get a 1. So we'll say that's first, right? First. And this will be second. And in this one, I get a 1, 2, 3, 4, 5, 6. So you can get B1, B2, B3, B4, B5, or blue 6. I'll say blue instead of B. You can get red 1, red 2, red, and then 3, red, and then 4, red, and then 5, red, and then 6. Or you could get yellow 1, yellow then 2, yellow then 3, yellow then 4, yellow then 5, yellow then 6. All right. You could have also, this is going to be kind of interesting. I'll do the tree diagram this way. You could do blue, spin red, spin yellow. You could have done blue 1, blue 2, blue 3, blue 4, blue 5, blue 6. Or you could have done red 1, red 2, red 3, red 4, red 5, red 6. I'm sure you're wondering why I didn't just do it the other way. Me too at this point, but whatever. You get the point, right? Yellow 1, 2, 3, 4, 5, 6. Right? So, we could have done it this way. So, yellow and 2. Yellow, 2. That is one combination out of 6, 12, 18. So that's only 1 out of 18. Okay. Well, I'm actually going to put that right. We know what answer we should get. 1 out of 18. Right? But there must be an easier way. So, what are the chances you get a yellow? 1 out of 3. What are the chances that you roll a 2? 1 out of 6. Well, if you just multiply these, you get 1 out of 18. So, it's as simple as that. You could just skip over to the percent, which I forgot what 1/18 was. That's half of 1/9, so 0.055 maybe. Let's find out. Yes. 0.055, right? Yeah. Repeating, which is 5.55 repeating percent. All right. So let's use that same strategy. We're going to spin a red and roll a 2 or a 5. So probability of spinning in red is 1 out of 3. The probability of rolling a 2 or 5 is 2 out of 6. Because you can get a 2, like you can roll a 2 or you can roll a 5. So you have 2 chances of getting either one of those out of 6. We'll multiply across. 2 out of 18, which is 1 out of 9. That's our simplified fraction, which is 0.11 repeating, which is 11.11 repeating percent. And let's see if that matches. 2 out of 18. So we want a red 2 or 5. Red 2, red 5. That's 2 out of 18. But see how it's much easier just to multiply the fractions? So let's do it again. Red or blue, red or blue. That's 2 out of 3. And roll a number bigger than 2. So you can get a 3, 4, 5, or 6. So that's 4 chances. Oops. 4 chances out of 6. So 4 possibilities out of 6 total. So 8 18ths. And you know how to like simplify that. Oh, my bad. Divided by 2, we get 4. Divided by 2, we get 9. And that's a reduced fraction. And you know how to do the rest. Let's try this. We have a bunch because it gets there's a tiny bit more nuance. This is an easy lesson. I added some. You flip a coin and then roll a die, 6-sided die. What's the probability that heads up an even number? Probability of heads up is 1 out of 2. Probability even number, well, you can get a 2, a 4, or a 6. So that's 3 out of 6 possibilities. So you get 3 out of 12, which is 1 out of 4. We divide by 3, right? In case you want to see it. Which is 0.25, which is 25%. All right, there's a bag, or we have a bag with 4 watermelon Jolly Ranchers and 6 cherry. You pick one, you put it back, and you pick another. So what's the probability you get a watermelon and then a cherry? Watermelon, so there's 4 watermelon out of a combined 10. Right? Well, I'll reduce it later. I don't have to reduce it now. And then I put it back, so now there's 10 again. And this time it's a cherry, so there's 6. So this is the probability of a watermelon. And this is the probability of getting a cherry. So a probability of watermelon and then a cherry is 24 out of 100. Oh man, I should have reduced earlier. All right, so divide by 2, I get 12 50ths. Divide by 2 again, I get 6 25ths. And if you prefer, you could have reduced it already here. You would get 2/5 times, I'm gonna do this so y'all get confused later. So 2/5 times 3/5, and you'll get 6 25ths. So you either could reduce it after you get your answer or before. Either way, you end up with that, and then put the decimal, and then put the percent. There's a bag with 4 watermelon. Okay, same one, 4 watermelon, 6 cherry. You pick one, and then you leave it out, and then you pick another one. All right, so let's think about this. To get the watermelon, it's 4 out of 10, right? All right, you don't put it back this time. So if you were to go in a second time, you wouldn't have 10 anymore total. You would only have 9. Because we assumed that you took out a watermelon. So if we assume that that happened, that means there's 1 less at this point. And there's still 4 cherry in. So 4 out of 9 are cherry. Remember that we had 6 out of 9. So we had a 4 in 10 chance of getting a watermelon. We assume it's out. So now we have 9 left, and there's still 6 cherries left. 24 out of 90. And then you can reduce and do all that stuff, right? Okay, so there's the bag with 4, so same thing. All right, you pick one, you leave it out, and you pick another one. So remember, we're not replacing it. So probability of a cherry and then a cherry. So the probability of a cherry is 6 out of 10 initially. Now, if we assume we took a cherry out, how many candies do we have left? We have 9. So how many cherries would be left out of the 9? There would be 6, because remember, there was that 6 out of 10 chance that you took it the first time. If we assume we actually took one out, you only have 9 left, and you would only have 5 cherries left because you assumed that you already took one out. So this is the probability of getting a cherry, of cherry number 2, we'll say without replacement. That's what we call it. If you don't replace something, you have less. In this case, we have 1 less cherry, and then go from here. So let's look back at number 6 and number 7 real fast. So in this one, we had a watermelon, 4 in 10 chance. We assumed we took one out, so now we have 9 left. And then we tried to take a cherry, but remember there were 6 cherries in there, so we're good. In this one, there was a 6 in 10 chance I took a cherry out. But assuming that happened, there's 1 less cherry, so you only have 9 to choose from. And if you took a cherry out, then you only have 5 left. In this problem, number 6, the watermelon and the cherry hardly affect each other, right? If you take a watermelon, then you have 1 less to choose from. But over here, since you took it twice in a row, both numbers go down, not just the total number. Like the number of cherries and the total number go down. All right, thank you.